Hey, did you ever have one of those days where you wake up all bleary-eyed and stumble into the bathroom and have a shower, and you look at the alarm clock, and if you only got like 3 minutes to get out the door, so you dress yourself haphazardly and stumble out. You're making your way to the train station, and you have this strange feeling that something is off today. It seems like there's a lot less traffic, a lot fewer people out and about. You start to get this sinking suspicion as you're riding the train to work. And when you get there, you realize, yep, today was a holiday. Yeah, I just had one of those, so I'm not sure whether I'm happy about it or angry. I mean, I could have slept in. I could have spent all that time on the train sleeping. But on the other hand, it's like a free holiday. It's like something you weren't even looking for. Anyways, looks like I've got some spare time on my hands, so let's make another tutorial. Quick recap of lesson 5, or not so quick recap. Lesson 5, first thing we did was we learned how to increment a variable or increase it by some value. And you use this kind of syntax here, which may seem strange coming at it from a math point of view, but from programming it's perfectly straightforward. Just retrieve the value stored at x, then find the sum of that retrieved value and 1, and then store the result back into x. That's all this is saying. It's perfectly fine in programming, or at least in C++. Now, just one thing I thought of. This is something that you cannot do. 5 equals x. This is impossible in C++. We'll build the solution, and we get an error here. Oh no, you didn't! It says left operand must be L value. In compiler speak, an L value is anything you can store a value into. So generally it means variables. So the left operand must be a variable is what it's trying to say there and sort of failing at. And that makes sense because, I mean, this isn't algebra, right? You can't just, this isn't an equation saying that 5 is the same as x. Did it again. It's not what it's saying. What this is saying is store x into 5, or retrieve the value stored at x, and then store that value into 5. And what the hell does that mean? Storing a value into another value. That's crazy talk. So, no, don't ever try to do that. You will have shamed me greatly. So yeah, we learned how to increment, and then we learned how to create a variable outside of the compose frame function so that it persists even after the function has ended. And the place where we store that is in the we look in the game.h file, and we can declare our variable right here, right where I put this nice little comment here that says user variables. So we stick some variables in here, and then we can access them from any of these functions now, because these functions and these variables all belong to our game object. Alright, so yeah, you just put the variable declaration here instead of here, and now it stays alive. Damn it. The magnification doesn't, it goes back to, I don't know how that magnification works. I guess it works on a per file basis. Remembers what zoom you were using on that file. Okay. Yeah, I forgot in the last lesson to change the magnification again. Sorry about that. Yeah, so we learned how to declare our variables in the game object, which allows them to persist for the whole life of that object. And the last thing we learned was we learned how to initialize those variables by initializing them in the constructor. Now the constructor is it's a member function that has the same name as the object. So here is our constructor. Has the same name as the object, and here is where we can initialize all of the member variables of that object. Now, one thing I didn't talk about in very much detail was this part here, because this is different than all of our other functions here. I mean, all of our other functions, we do stuff within the braces, but in this function we have nothing within the braces, and we have this weird list here. And this is called the initializer list, and it is you can only make this for a constructor. If you try to do this with any other function, the compiler will say, go to hell. So the basic format for initializer list is after your function name here, you put a colon, and then you put the name of don't do that shit. There we go. Then you put the name of a variable, and then in parentheses after that name you put the value you want to initialize that variable to. So here we're initializing our graphics object with a hwind variable. Here we're initializing our keyboard with a kserver variable. And we're initializing our x and y with 400 and 300 respectively. Alright. Now the last thing that I wanted to talk about that I kind of glossed over in the last episode was the difference between a CPP file and a game file, and an H file. So here we have game.cpp and game.h. And so what's the difference between a CPP and an H? Damn it, I've got a freaking loud siren running in the background. It's messing me up. Shut up. Shut up, you ambulances. Can you please die quieter? That's better. Okay, so, yeah. The difference is that the game H files are used for declaration. They declare exactly what a game object is, what kind of functions it has, and what variables it contains. So this is the declaration of a game object. The CPP file here defines the behavior for all of the member functions that belong to the game object. So this kind of just sketches out the outline of the object, what functions it has and what variables it has. And the CPP file gives us the details about how the functions actually work. And that is the division of labor in C++. You have your CPP files and you have your H files. And there's a reason for dividing them up, not putting them in the same file. But I'm not going to talk about that right now. We'll get into that another day. Alright, so let's talk about the homework assignment after I have a swig of my ginger ale. Alright. So, in the last lesson, we made our cursor move around, but it was decidedly slow. So I gave you guys the challenge to speed things up a little bit and make it so that the cursor runs faster. Right now it's moving at 1 pixel per frame. And what I said was I wanted it to move by 3 pixels per frame. But I also want you to be able to change the speed if you press enter or if you press space. Space should make it go slower at the 1 pixel per frame speed. and enter should make it go hella fast at 8 pixels per frame. So here is how I would go about doing that. There are other ways of doing it, but this is the best way according to me. So first we're going to make a variable, and we're going to make the variable inside the function. So this is going to be one of those amnesia variables. We're going to give speed a value of 3. All right. Then we're going to check if keyboard dot enter is pressed. And damn you. And if it is pressed, we're going to set speed to 8. Right? That's what I was saying. If enter is being pressed, we want the speed to be faster. And likewise, if keyboard dot can't type with shit. Today or any other day. Space speed equals 1. That makes sense. And of course the last step is to replace all these hard-coded 1s with our speed variable so that the speed will change based on what keys are being pressed. So I'll just go Control F here. Quick replace, we'll replace 1 with speed. Replace all. And there you have it. So with any luck, this should give us our 3-speed manual transmission. So we're moving quicker, moving along with a good click here. Add a good click. Now if we press the enter key, then oh yeah, we're just blazing. And space will allow us to position our cursor with single pixel accuracy if you're fast enough. So it's that simple. It's not I don't think it was that difficult of a challenge. Now I mean, you could have declared the speed variable inside the game object, but there's no reason to do that because I mean it's not a value that you have to that you want to store over a long period of time. It just matters within this single frame according to what buttons are being pressed, what the speed is going to be. So there's no need to declare it within the game object. I didn't explain that too well, but I hope it's self-evident that speed doesn't need to be a part of the game object. Alright, so now let's get started on today's topic. Now there's been a flaw with our a flaw with our little program. Well, there's many flaws, but one of the most glaring flaws is the fact that it crashes when you go off the screen, right? And before it wasn't a big deal because we didn't have a lot of freedom to move the cursor around. As long as you didn't program it in a stupid spot, it would work fine. But now, the imaginary user who we suppose is using this program has the freedom to move the cursor wherever the hell they want. So now they have the freedom to totally screw shit up. And that's not a good thing in general. Generally, you do not want to give the user the ability to crash the game, right? You can't just tell them, oh, it's your fault, you weren't supposed to go there, stupid. Nah, that's not how it works. So we need to find a way to restrict the cursor so that it does not go off the screen. And I am going to give you that way right now. It's quite simple. Again, we'll be using an if statement, not an HF statement, an 8F. Alright, so we're going to say if x is greater than... No. less than 5. X equals 5. I think you can probably guess what this statement does here, but let me just show you. So we have our cursor. Now if I try to move to the left, it gets stuck at the edge of the screen and doesn't just fly off or wrap around or do something stupid like that. And the reason is because obviously if I keep pressing left, it keeps trying to decrement the value lower than 5. But as soon as it does that, this statement becomes true and the x value gets assigned, 5 gets assigned to the x value again. So now it's impossible to go below 5 for our x, because as soon as you do that, we just shove 5 back into x. We're clamping the x value to a minimum of 5. This is a new operand. It is called a comparison operator. So like other operators, like the plus and the minus, it takes two values, a left hand and a right hand operand, and it gives us a result. But unlike our arithmetic operator, it doesn't give us a number result. It gives us a Boolean result, which is a true or a false. So this statement evaluates to true or false, which, if you remember, is the kind of value that if likes to see. If is looking for true or false. If it's true, we execute this. If it's false, we skip it, right? So what this comparator does is it says, okay, look at x, look at 5, and is x less than 5? Or it's saying x is less than 5. And if that's true, then the operator returns true. And we execute this, which is to set it to 5. And if it's false, we skip it, right? So comparison operator, very good, very useful. As you can imagine, it has a complement, it has a partner here. And that is the greater than operator. So if we do this, now we're saying if x exceeds 794, then it gets clamped to 794. So now our crosshairs can only exist at the locations of between 5 and 794, which happens to be the extent of the screen when you take into account the wings that are at the edges of the crosshairs. So, likewise, we should do the same for y. So I'll copy, paste, and I will go Control F, and we'll replace x with y. Right? And then we want to replace 794 with 594. And now we can no longer crash our program. At least not as easily as we could before. So that's a lot nicer. It's a quite an improvement, I would say. All right. So there you have your comparison operators, less than or greater than. They take two numerical values and they poop out a Boolean value. And we're going to be using these a lot, because you end up comparing crap a lot in when you're programming. And usually the result of that comparison determines whether you take a branch or whether you skip it. Okay, so yeah, so that was actually pretty short. This lesson's material was pretty short, but very important, so make sure you understand it thoroughly. And now, I gotta give you guys an assignment. Now while the, oops, I didn't want to move that. There we go. While the subject matter of today's lesson was short and simple, I think here we go. I think the assignment will prove to be a little more challenging than assignments we've had up until now. So if you look at our crosshairs here, it is teal, right? So its color is teal, and now it's white. So this is the comparison that we implemented to restrict our crosshairs to the window. But I've added a little one little twist, and that is that when the crosshairs when they enter the center portion of the screen, so there is a rectangular area in the center of our window here, and when they are in that rectangular area, the crosshairs change color. I don't care what color they change color to, but the idea is that when they're outside of that area, they are white, and when they are inside some rectangular area on the screen, they change color. And that is your mission. I don't know if it sounds simple, but I think it'll prove a pretty good challenge for you. Now, I just want to let you know that you do have all of the tools required to complete this assignment. You can complete it using only the stuff that I've taught you so far about C++. But unlike the other lessons, it's not just going to be copy and paste this stuff and change a few variable names or a few numbers. You're going to have to do something a little bit different. You're going to be using ifs, and you're going to be using comparisons, but you're going to be using them a little different than we used the if statement so far. So it's kind of a little riddle here, and I want to see if you guys can solve it or not. Don't if you can't figure it out, don't bang your head against the wall. I will show you the answer eventually, but give it a good try and see if you can figure out how to implement. Oh, this is the wrong one. How to implement this this functionality. So that's my challenge to you guys. Michael J. Fox!
Game over, yeah!